Hey everyone, welcome back to Tech Canon, Chapter 4. In Chapter 4, we're going to be going over technical questions. This is a part 1 of the series for technical questions. I'm going to start by going over a method you can use to walk through creating your algorithms and writing efficient code during interviews. And then the second part will focus on just two data structures. For now, we're going to go over hash maps and linked lists. So let's get into it. LEBOWIT, you're wondering what this even stands for, I'm sure. LEBOWIT is an abbreviation for some critical steps that I would recommend you take when you are faced with a coding problem, be it during an interview or even while you're solving algorithms on your own. This method is guaranteed to help you get to an optimized solution within a limited amount of time as you would face during technical interviews. So what does LEBOWIT stand for? Listen, example, brute force, optimize, walk through, implement, and then test your code. I'm going to go over each of the steps and walk through a scenario with you so you understand how to use each of these. Listen. So this is the very first and most important part for your software engineering interview problems. Usually when you are given a software engineering interview question, you're given a prompt for you to create an efficient algorithm to solve. Say for example, you're told to write an algorithm that determines if a number is even or odd. This is the scenario I'll use for the rest of this chapter. You want to listen to the details of your question. Pay attention to what the problem says, even and odd numbers. From there, you have to think, what is an even number? What is an odd number? Details. You also want to try to understand the examples. In this scenario, even and odd numbers are pretty straightforward. So examples in this case would just be even numbers 2, 4, 6, 8, and odd numbers 1, 3, 5, 7. Then you also want to pay attention to any constraints your algorithm might be suggesting. So for example, saying print all even and odd numbers is very vague. Does your problem have a constraint of printing all even and odd numbers between 1 and 100? Is it asking for all even and odd numbers between 1 and 10? So these are details you want to pay attention to before you even get into thinking of a solution. Next, example. Before you think about solving the problem, you have to try to come up with examples of your own. In this case, 2, 4, 6, 8 are even numbers. Then an example you could ask, assuming even and odd numbers were not as common knowledge, is 48 an even number? You run through that with your interviewer. In more complex scenarios, obviously you wouldn't want to be asking your interviewer if 48 is an even number. Next, you want to validate your understanding with your example. Just like I said with 48, ask your interviewer. So for example, if I was to print out 48, would you consider that as an even number that falls between X and Y range? The next phase, after you have listened to the details, paid attention to every single detail of your interview problem, you've run through examples of your own to make sure you understand the problem statement. You want to try to come up with a brute force solution. This means coming up with an algorithm that solves the problem. At this stage, don't worry about how efficient your algorithm is. And even when I say write your algorithm here, you don't need to focus on coding syntax. I'd actually recommend just writing down actual steps in plain English for what your algorithm is going to do. For example, say you're given a problem to write a function that checks if a value is an even or odd number. What you want to do here is come up with the easiest solution you can think of just off the top of your head. Don't come up with any complex algorithms yet. So say you're given a value X, and then you want to know if it's even or odd. How do you do that? For example, let's take 5. 5 divided by 2. When you divide 5 by 2, you have 2 and then there's 1 left. So that tells you that 5 is an odd number. If you divide 4 by 2, it divides perfectly and you have 2. So 4 is an even number, 5 is an odd number. Now, how do you write an algorithm for this? You notice we're checking for what is remaining after dividing by 2. So checking what is left during a division is an operation known as modulus. So if you were to do 5 modulo 2, you would get 1, which is what is remaining after the even division. A brute force solution here could look like given value x, divide x by 2, see if x divided by 2 gives a whole number or if it's a decimal number. Or you could go directly into doing whatever value you're given modulo 2 and see if the remainder or the answer is 0 or 1. Optimize. So in optimizing your algorithm, there are certain things you want to look out for. You want to look for bottlenecks in your algorithm, look for unnecessary or unneeded work, see if there's something you can remove. Maybe you had duplicates. For example, you could have 2 for loops in an algorithm that are separately doing the same thing. See if you could combine those. Next, you want to look for data structures that you could use to help optimize some of the operations you're doing in your algorithm. After optimizing your algorithm, notice we still haven't written any code yet. In all the stages we went through, you listen for details. Example, you walked through or thought about an example based on the problem and validated your understanding with your interviewer. B, you created a brute force solution to solve the problem statement. O, optimize. You looked around to make sure you didn't have any duplicate code. You solved for any bottlenecks that your algorithm may have. Next, you want to walk through this optimized solution with your interviewer. So I'd recommend having, if you can, a whiteboard of some sorts. Usually either a physical whiteboard or a virtual whiteboard is fine as well. You want to walk through your algorithm with your interviewer just so they understand your algorithm as well as yourself. It helps you visualize your algorithm and understand your solution even better. So in the example where, let's say we're taking the problem where you have to write a function that determines if a number is an even number or an odd number. In simulating your algorithm, you would walk through an example given, let's say 50. So you tell your interviewer or yourself that your algorithm first stage is to divide or do a modulo 2 of whatever value you're given. So 50 modulus 2, that's the first stage. Next stage is the solution. 50 modulo 2 is 0. So what we're doing is checking if value equals 0, then even, else odd. So 50 modulo 2 is 0. 0 equals 0. Number equals even. So you've walked through every stage of your algorithm. You could also walk through an odd example just so your full algorithm is covered. So you're given, say, 51. 51 modulo 2 is 1. If value equals 0, even. In that case, you would skip the if condition since the solution you got was 1, and then it would automatically fall into the else condition and print out odd. You're walking through both parts of your algorithm. So this also helps you verify your logic. As you're walking through, you might identify gaps, you might identify repeated work, and it would help your interviewer understand your algorithm as well as yourself. Now, once you've walked through your algorithm, this is where you actually write code. So as I mentioned, you're not writing any actual code up to this point. The early stages would help you formalize your algorithm, help you understand what gaps and edge cases might exist in your algorithm. So you want to try to write beautiful code at this point. So at the implementation stage, you've already gone over your algorithm, what conditions exist, what constraints. So now it's just about writing beautiful code. Make sure your variable names are explicit. Say you're checking if a number is even or odd. You can have a variable is even, a boolean variable named is even, boolean named is odd. Just try to come up with names that better explain your algorithm so whoever is looking at your code easily understands what every stage is doing. Next, you want to make sure you can modularize your code as much as possible. Say you have a lot of code that is figuring out, for example, if 5 modulo 2 gives you an even or odd number, you can abstract out that function to a separate function and then call that method within your main method. Now, also, of course, you want to check for errors, check for syntax errors, check for common errors like index out of bounds in your for loops and the likes. Now, once you've implemented your code, the last and definitely most important stage is testing your code. So never during an interview just implement your code and leave it to your interviewers. Never just write it and say, okay, I'm done. That's your problem now. You have to try to test your solution in front of your interviewer. So most what I usually like to do is take an example, a very uncommon example. I wouldn't pick an example that my interviewer already gave me. Or sometimes that's fine as well if it's a very robust example. You walk through your solution, your algorithm, test with every single step and make sure all your steps are covered. Now, you also look out for common bugs that might happen, like checking values within a for loop. Make sure you avoid common mistakes. Um, you also want to test multiple cases, test small cases, test bigger cases, and most importantly, you also want to test edge cases. Next, we're going into data structures. So I'll be covering two data structures in this chapter, one of them being hash maps and the second being linked lists. What are hash maps? During software engineering interviews, hash maps are one of the most used data structure of their because of two things. One of them being the key value storage, and second and most important reason why hash maps are used a lot, this is very important, take note, is because of the fast lookup time. Well, let me give you the formal definition of a hash map. Hash maps are data structures that are used to store data in a key value format. If you were to store some values in a data structure like an array, you would simply add them to the array and list them in order 1, 2, 3. But in a hash map, you would have a key that points to your actual value. So that is one of the most important things about hash maps, the fact that there's a key value pair. The key acts as a link to be able to retrieve your values, as opposed to arrays and some other data structures where the values are ordered. In a hash maps, the values do not need to be ordered. The key value pair is easily represented in the diagram to the right, where you can see for each value 1, for example, there's a key with the actual integer 1 and the value is 1 as a string. Key 2 integer, value 2 string. Now, there are three major methods to hash maps. Of course, this can be expanded on and modified as long as there's code to be written. People will write code. So there are many more methods you might see online, but these are the three most important methods for hash maps. One of them being put. Hashmap.put is when you insert a new value into a hash map. So whenever you insert a value into a hash map, you need to include its key and the value. The key has to be unique to that particular hash map. So like say you are creating a hash map that keeps count of how many apples are in the kitchen or something. You create the key apple, and the value can be the count of how many apples. So let's say you have apple with 10 as the value. You cannot create another hash map record with apple as the key. You'd have to rename it something else. Now, the get method, this is the most used method because the hash map, like I said previously, allows you retrieve values from your data store in constant lookup time O of 1, which is the most valued feature of hash maps. So you can retrieve a value from your store without having to iterate through a list. For example, if you were to try to read a value out of a typical array that was in the middle, you would have to go from point A, navigate all the way through your array till you get to your certain point where the value is to read that. But with hash maps, all you have to do is know the key of where that value is stored, and you can just call it get on that direct value. Now, delete works the same way as get. If you want to delete an element from a hash map, you would just need the key, which once you call delete on the key, deletes that value from the hash map. So essentially, the key value pair is the most crucial part. The key acts as a pointer to your actual storage location. Next data structure I'd like to go over is linked lists. What are linked lists? A linked list is a data structure that represents a series of connected nodes. Now, that sounds way more complex than it is, but it's simply a list that shows a connection between different elements. So in that case, we call each element a node. So if we were to walk through an example of what a linked list looks like, this is what a node would typically look like. It contains two parts, which on the code on lines 3 and 4 on the code on the right of the screen, you can see next, which is the pointer to the next element, and then a variable that holds the actual data, which is 2 in this example. So a linked list pretty much works like this. The next points you to the node for the next element. Then you have the actual value. Then the very next element, you have the pointer as well, pointing to 7, a pointer to 1. So let's say we wanted to add an element to the end of our linked list, which is one of the most important methods for linked lists. How do we do this? Now, just thinking visually, do not even worry about the code yet. So if you're looking at it visually, what would be the easiest way to add an element to the end of this linked list? All you'd have to do is create a new node. In this case, we'll create 5. And then we point from the next of the very last element all the way to our new element. Now, if we're to walk through what we have in the code as well, that's pretty much what the code is doing. On line 11, we create a new node with the value 5. On line 12, n equals this. So we're pretty much just starting from the start of our linked list, which would be 2 in this case. And then while n.next is not equal to null. So if you notice in a linked list, the very last element, the pointer is always null, which is what you see on 5. So in this case where 5 was not yet inserted, when we start from 2, the while loop, all it is doing is checking to find the very last element in the linked list. So while n.next is not equal to null, n equals n.next. That sounds more complex than it is. But all it's doing is, while this element's next element is not empty, make the current element the next one. So take the next one and keep going. And that while loop goes all the way until it reaches the very last element. Once that point has been gotten to, then on line 16, we point the last element done next to our new node, which is called end in this scenario. Now, a second and very important method for linked list is deleting a node from a linked list. How do you delete a node from a linked list? So thinking visually again, if you are going to try to delete a node from this linked list, let's say we want to delete 7. What's the easiest way to do this? you could say, oh, loop through them, and then whenever you find 7, just remove it. But the most important thing here is removing that connection between the nodes. So let's walk through a scenario where we want to remove 7. The first thing would be to delete that node, which is this. But now this is no longer a linked list. You have two separate data structures disconnected. And a linked list, like we mentioned, represents a connection of nodes. So to remove 7 successfully, all you'd have to do here is create a pointer from 4 all the way to 1, skipping 7 and thereby removing 7 from the linked list itself. Now, if we look through the algorithm on the right, I'll walk through this briefly on how to delete the node. So the very first check we have on line 3 is if the head of the node is equal to null, return null. So if you have an empty linked list, the head will be null. So you can't delete something from an already empty list. So we just return null. Skipping that, we go to line 5, where we instantiate the head of our node, which is the starting point 2. And then on line 7, we check if n.data, which is 2 in this case, is equal to value, our 7. Value is 7 in our scenario. Return head.next. So if you were trying to remove the very first element of a linked list, which is what condition 7 is checking for, all you'd have to do is remove the pointer from the first node. So now you're returning a linked list that starts from the second element, which is returning head.next, which would be 4 in this example. But in our scenario, we're working through removing 7. So in that case, we'll skip line 7 since n.data, which is 2, is not equal to 7. So we're skipping that line. Now from lines 11, you do the loop again, which is a while loop, looking for the very last element of the linked list. So in iterating through linked list, this while loop is going to be your best friend. If you notice, we use it in the add method, and we're using it again in the delete method. So you're pretty much walking through until you find where n.next equals null, which is the last element. So while we're iterating through, as we go through every one, we first check, is n.next.data equal to our value? So for example, we're still at n equals the very first element. N.next will be 4, and the data is 4. If that is equal to our value, then what we do, like I mentioned, is to change that connection, which is what is happening on line 13. We're changing the connection. So n.next, which is 4's next, is now going to be equal to 7's next. 7's next was 1, remember? And on line 13, all we're doing is changing that from pointing to 7 to change it to point to 7's next, which is n.next.next, which is 1. And once we've done that, it means we've deleted successfully. Then we can return head, which is returning the head of the linked list. And we're pretty much done deleting the node from that linked list. Now, there are other examples of linked lists, which this is a double linked list. You can see on the left-hand side. Doubly linked list is pretty much just a variation of the linked list that also contains a value that points to, besides just pointing to the next element, it also points to the previous element. So 2 would have previous pointing to null, since there's no element before it. Next would be pointing to 4. 4 would have its previous pointer pointing to 2. Next would be pointing to 7. So if you were to write an algorithm to add or remove elements from a doubly linked list, besides just updating one connection, now you have 2 connections to worry about. So this is just another variation of a linked list. I'd recommend writing algorithms to add or remove elements from a doubly linked list as a practice exercise for this chapter. So we went over 2 important things in this chapter. Number 1 being LEBOWIT, which is a trusted method to walk through coming up with algorithms and solving technical problems during interviews and even on your own. Next, we talked about two data structures which are really important for solving technical problems and are usually recurring themes during interviews. One of them being hash maps, second being linked lists. And we talked about their methods and how they are used. Thanks for listening. Looking forward to seeing you in the next section.